Okay, so in this video I'll write a code for a classification problem. I'll be using branch models, and I'll try to keep it very realistic. Normally when you write the code, you end up typing wrong syntax, and that's very natural. So that is the reason I'll just keep it very natural. I'll just import the library first. Import pandas as PD, and then what I'll do is I will read the data. So data here is wine data. Let me just data equal to read underscore CSV, and then it's after W wine, wine data set. Now ideally if I'm working on Twitter data or some data which have special character, I need to add encoding here as well, but the data is very clean this here. So what I'll do is, let me just see the data dot head. Okay, now we need to create a problem, classification problem out of it. So I need to see the dependent variable here. Oh, this could be quality, and it seems to be, it's a numerical value which varies between, let me see. So I just describe to see how it varies, and I can say minimum value of and maximum value is 3 to 9. So what I'll do is I'll just cut it. I'll just try to create categories, 3 categories there. I can create more categories as well, but let's just try to keep it to 3. pd.cut. Now the data is data, quality. I need to specify the bins. It's a very convenient way of doing it. So bins equal to 0 to, let's say 4 to 6 to 10. Well, let me keep it 5. Either ways we'll see the distribution. Let me just run it. I need to mention the labels as well. So labels would be 0, 1 and 2. Okay, let's see the output. Okay, cut labels. Okay, I forgot to type L. Oh, that's being very realistic. Okay, so why can't I just try to see the distribution? For distribution, let me try to install or import matplot lib.pyplot import plt as plt. Okay. Let me run it again. I don't say habit. I just repeat. Run it again and again. Anyways, why? So let me do one thing. plt dot histogram. Let's draw a histogram. Y underscore train, and let bins equal to 3. Let's see the distribution. Okay, so from 0. Okay, so this is not. It's very skewed. Let's do it 5 here and see how it turns out to be. Okay, this looks good. So let's keep it that way only. Let me. Okay. Now let me create a category out of it, right? So I have currently label 0 and 2. 0, 1, 2. Okay. I need to create the encode it as well, right? So if it's the output layer, the outermost output layer in neural network, it needs to be in that format. So let me do one thing. Let me import. I need to drop this column as well. Okay. Before doing that, let me just create a training data set as well. Train equal to data dot drop columns equal to quality and style. That's a text column. I don't need it. I just need to show how we do the modeling here, so it's not that important. Okay, so train is this, and okay, great. So let me also see what all columns are there in train. Dot head. Okay, so I don't. So okay, that's cool. I need to also scale it as well. Let's do the scaling as well. It will be easier for model actually. So let me just import from the great sklearn library, sklearn dot So I need to do is scale, so that would come under pre-processing. Let me see. Pre-processing, import from SQL and import. I think we got min-max scaler. Let me see if I'm writing the right syntax. Min-max scaler. Great, awesome. So what I'll do is I'll just create the object here. Scalar equal to. Let me copy it directly. Okay, so what I'll do is okay, great. Now what I need to do is to fit. For that I need to do is dot. Let me see the syntax. Yes, fit transform. So for fit transform, I'll just pass the whole data frame. Actually, I can pass columns as well, but why not? I'll just transform the whole data frame. X train equal to. Okay, let me run it around. Okay, that's cool. Let me see the value. Okay, how it looks like. Oh, that's brilliant. So I can see the scaled value here. I just feel really good seeing data in this format. Anyways, so I have train, I have labels, I have dependent independent variables. Now the next thing I need to do is what I was doing there. I have it. Oh, I have to encode it as well, right? So for that, let me think. The library is from sklearn dot. What I need to do is I forgot. Okay, encoding. Yeah, one hot encoder dot pre-processing only. I guess we'll see whether I'm correct. Import one hot encoder. It'll encode. It's a very good. Thank God I'm correct. Anyways, so let's say encoder equal to one hot encoder. I create an object. Then what's the input? So it's y underscore train. Y underscore train equal to y. I need to create in 2 dimensions actually. So that's how this function accept the value. So y underscore train. I have to convert to np array as well. Np dot array y underscore train dot reshape. Yeah, I hope it works. NP is not defined, so I have to import the numpy as well. Import numpy as np. Okay, I'll just take a step back. So what I've done till now is I just read the data and cut it into categories. I need to create a dependent variable here. So y underscore train is a dependent variable. X underscore train. So I don't need, because I also need to have the independent variables. So ideally what we do is we'll dig down, drill down and analyze different columns. But as per my experience, it's always better to create a benchmark to start with. So benchmark would be, it's a very conservative sort of benchmark, because I'm not doing any pre-processing, only the min-max scaling. And let's see what the output would be. Then probably we can come back and try to do some more feature engineering, transformations and all. Okay, so I need to do is fit. Yeah, y under code equal to encoder dot fit y underscore train. Let's see how it looks like. Okay, and in code is, if I go and see in code, this okay, one hot encoder. Now in code dot transform y underscore train. Let me call equal to encoded. Okay, so uh, sparse matrix dot to array. Okay, okay, encoded. If I see now, okay, I can see. So these are the how it looks like. So it makes sense because in the outermost layer, I'll be using cross entropy basically to see how how some basically to optimize my cost function. So it should be in this format only. This would be my actual output. It's actually the true distribution. So when we calculate cross entropy, you would see like it's like px log qx, negative of px log qx. Qx is the distribution which your model is generating, and the outermost layer would contain that, and px is something which is there. It's now this definition is coming totally out of information theory. If you can go and check out cross entropy, h of pq, p is PQ where h of p is a true distribution, and then you have KL divergence. Anyways, you can go out and check that thing out. We're not having this session to explain that, but just to show without any internet, if you want to run a model classification model, how you can do it. So okay, so we have created the outermost layer. Now what we need to do is we need to create a model now, right? So for that, let's go. We are creating branch model here. Okay, so let's say entry equal to input. I need to provide the shape as well. Shape is of input is x underscore train dot shape columns comma bracket. Okay, so this is the shape here, and it's a good practice to name the layer as well. So I would rather name it like entry. Now the input is I don't know. So let me import this library from Tensorflow dot input is what layers. Yeah, layers. Import dense. That will go on next layer, and this input. I'll just try to incorporate as a notice what is required. What's that? Tensorflow dot keras. Okay, it's keras dot layers. Cool. Kind of file. I didn't. Okay, so that's very realistic, right? That's a funny mistakes. So we have the first layer in place. I'll create the first hidden layer one. Okay, and I'll call it dense. See, it's numerical data, so I don't need we need that much number of layers. Let's keep it 128. And activation function, I think by empirically ReLU has proved to be one of the best. I think the better activation function to introduce non-linearity. Okay, so this is one. If I run it, okay, what's the problem here? Dense, entry, hidden. What am I missing? Let's see. CUDA runtime GPU failed. Busy or unavailable. What is that? Let me try it again. Dense, entry, hidden one. Activation equal to ReLU entry. I think it should work. I don't know why it's not working. Okay, let me go up and see from where the error is coming. Hidden one, dense, 128 activation equal to dense layer. It is shape equal to x dot train shape one equal to entry. Okay, I think I have imported dense. Let me see. Yes. CUDA runtime plus initializing GPU failed. It's all good device are busy available. So I don't want to use CUDA device. Let me see. No problem here. do one thing. Let me restart the kernel. Okay, thank you Microsoft. Oh, but it's not Microsoft, it's a Linux machine. Okay, hidden 2 equal to same dense. Let me get 256. Actually I'm overkilling here. I don't need that much compute to actually, complexity or capacity to solve this problem. But anyways, if it was a text based problem, I think we would need a lot more than that. But anyways, hidden 1, hidden 2, let's keep hidden 3 as well. I need 99% accuracy. Let me use 128 then. Okay, activation equal to relu hidden 2. Okay, I have so I need to create an outermost layer. Let me call it exit. Okay, equal to dense. Since it's an outermost layer, it needs to have y underscore train dot shape dot 1. Okay, let me see what the value exactly. It ideally should be 3 because that's the number of categories I have. Let me just put it here. Just type it y underscore train dot shape 1. Hi, what is that? Let me see. Okay, it's encoded actually. That's a reason. That's a good practice to check it out. So it has to be the shape 1. That's okay. That's exactly what I need. Let me copy it down and okay, that's done. Activation. Now here the activation would actually be softmax. So I'll put softmax and this has to be hidden 3. Okay, let me do it. Now, okay, great. Now the model should be equal to define the model. Okay, entry and exit. That's how we do it. Okay, I'm not models. I have to import this from tensorflow.keras.models. Import model. Let's hope it works. Oh, flow. Bravo. Okay, so we have a model. Now what we need to do is model.compile. For that I need optimizer. Okay, model.compile. Optimizer equal to the best optimizer as per my experience. Learning underscore rate equal to 0. Okay, let's do one thing. Because normally in text NLP problem we have a very small learning rate. Let's keep it small and see how it affects my training. Especially in case of this kind of problem where I have integers, not text-based data. Okay, so that's about it. And loss also have to, and loss equal to output categorical cross entropy. Okay, so this has to be okay. The outputs. Okay, so this is important. When you're creating the outermost layer, it's better to name it. I'll name it like output. It helps. It helps. Really helps a lot. So let me run it. Great. Let me see if it works. Oh, the bracket is not there. Okay. So I have compiled the model. So I'm seeing an error because it's not mode, it's model. And I'll run it again. Adam, who is Adam? So I have to import Adam. Okay, from TensorFlow.optimizers. I hope, but I will correct almost all the time here. Optimizer. import Adam. Let me see if it works. Oh, optimizers from Tensor. Let's see if it works. From Tensorflow. Okay, to Keras should be there. No, Keras.optimizer. So, optimizers. Great. Let me go down. Okay. Now I need to fit the model. For model.fit, what I need to do is I need to provide the relevant input here. So let's see x.train y underscore sorry, it's encoded. That's the name of. I think I should have chosen a better name, but anyways, it's encoded. And then I have to specify, I think, batch underscore size. Let's say batch size is 2200 or 256. Okay, we'll wait. Epochs, how many time I want my model to go through all the data. Let's say 20. Okay, so I'm not using any validation set here or even test train split because I want to keep wanted to keep it very simple. Otherwise, we can use sklearn dot. I think pre-processing you have that train test split method. Which you can call and do a stratified sort of a sampling and create those train and validation set, but we're not doing it. What we are doing is we are just doing this. Great. So see, the model is running now. The loss is pretty high, and if I have to see the accuracy in classification problems, I most of the time rely on my classification report. For that I need sklearn dot matrix import classification underscore report. I hope 100% correct. Okay, so what I'll do is I'll just print the report here. I need to predict as well first. Okay, let's say predict equal to model dot predict, and what I'm predicting is x underscore train. This is my dependent data. Now this data would actually be in in a different format. It's like this, so I need to pick up the maximum probability here. So for that, what I'll do is list comprehension for IM pred. Okay, np.arg max I think this should work. Okay, great. Now when I do pred, I see the actual labels. Okay, it's all 1 1. Let me see if we have 2 or 3. I don't see any 3. Let me just see if there's not any problem. Let me see. There's only 1. I don't see any 2 here. Let me see the distribution, how the data looks like. Okay, dot hist pred bin equal to 3. Okay, there is. Okay, see, the model is not that great. That's why we are seeing a lot of ones. So it's very important to see the data. Okay, it's fine, but the reason is actually the model is not that great. It's predicting mainly 1s and 2s. No 0 here. No 0 category. Anyways, let me just delete this. So I have this. So let me just see the classification report. Print classification report /n classification report. Okay, why? Sorry, predicted, and the actual was y underscore train, if I'm not mistaken. Let me move up and see if that is the. Okay, while I was encoding, okay, I'm not encoder, I have y underscore train. Okay. Let me print y underscore train. I think I have changed the shape. I need to change it back again. Let's see. No harm in saying. So yes, Not sure if it's created a problem. Let me do one thing. Let me just rename this. Okay, clear underscore. Either way, it won't be used. Okay. Okay. So y underscore train would not change. Let me run it again. Very bad practice. I think one should have very descriptive variable name. Anyways, okay, the reshape is not there. Okay, I know the reason. So. Okay, yeah, I did not change it here. So let me run. Okay, so the model, I ran the model and I have class. So look here. So the accuracy is 35%. Oh, poor, very poor. It doesn't look good. Let me do one thing. Let me put a slash on here. Okay, is this slash or this slash? Okay, so look much better. Support is 228. Okay, let me improve the model here. The first thing I'll do is, it's too slow. Let me make it like this. Cross entropy and epochs. So batch size seems to be fine. Let's see if I make this change, how the output looks like. Okay, see, now you can see the loss coming down. So what I'll do is I'll just increase the number of epochs. Let me make it like 100. And the batch size, let me decrease it 128. And now see how the output looks like. Okay, so the loss is decreasing here now. 0.5. Okay, just for the sake of this video, I think let's just go ahead with this. Okay. Okay, now I see predicted value. Let me see the classification report. Great. Now you can see this is a minor change in the hyperparameter resulted in accuracy of around 90%. And weighted average or macro average around 90%. Sorry. So we definitely can tweak. There's a lot of scope for us to actually improve this model. But what we have effectively done here is, it's hardly anything. We just took the data, categorized it, scaled it, and then encoded it, and then finally created a simple model. And the beauty of this this hidden branch model is that you can have multiple cost function here. You don't need to have just one cost function here, because a lot of time when you're solving business problem, for example, you have a textual data and you want to find sentiment as well as find some categorization. So you can use a simple model. You don't need a model in series where your accuracy is decreased because it's in series, right? You multiply the accuracy of both the models to get the final accuracy. So it's better to have a single model in those situations and have a better accuracy, better maintenance of model. And so this is probably it's an experiment stage. So normally when we are when we're actually developing models for scaling purpose, we actually need to create the py file. We actually then embed that py file into a job and create those pipelines using MLOps. Using those pipelines, we end up creating either a Docker image or simple weights and inference file we share with the other team, multiple ways. So that's more of MLOps sort of side. But again, the scope of this video is mainly to show you how you can quickly develop any model within 15 minutes, any classification model or regression model or branch model like I was talking about. We can have multiple heads here as well, 2 different cost functions. So that's about it from this video. If you have any query that you want me to work on any other video, I'll be happy to do that. But that actually is my first video. I'm not good at this. I just thought, why not work on a video where I can just create a simple model for somebody who is just starting working in machine learning, and they want to taste the high you get when you run a model, get the accuracy, and then obviously you get much more satisfaction when you solve the business problem. But anyways, that's all it from my side. Just post it in comments if you need anything from my side. Thank you.